Hello, our purpose of the day is I can find the axis of symmetry, vertex, and y-intercept of quadratic equations. We are looking at quadratic function basics. Chapter 9 covers quadratics. A quadratic means that we have an equation with a degree of 2, or the exponent is 2. So let's look at a couple of basics here. We see on the graph that is actually the graph of a quadratic function. I will get to that in just a little bit, the name of all the parts of each graph and what the graph is called, but first let's look at the parent function for a quadratic function. The parent function of any quadratic is f of x equals x squared. Now, f of x is just another notation for saying y. So y equals x squared is similar. F of x is the notation we will use with quadratics. Standard form for a quadratic is f of x equals ax squared plus bx plus c, where a is the coefficient in front of x squared, b is the coefficient in front of x, and c is just a number with no variable. The type of graph that we are going to be talking about with quadratics is called a parabola. Go ahead and say that a few times out loud. Parabola, parabola. And that is, if we look over here at the graph, that would be the blue line here, and that is a U-shaped graph. It can open upwards, it can open downwards here for quadratics. Axis of symmetry, the axis of symmetry is where we would solve for, and that actually, it's here in red in our graph. It cuts the parabola straight down the middle, so if you were to lay one side of the graph on the other, it would match up perfectly. So it goes right through the center of the graph and cuts the parabola in half. And how we find the axis of symmetry is it's an equation, because it's a line, it's a straight up and down equation. So it's x equals opposite of b over 2a, or negative b over 2a. Now the vertex is either the highest or lowest point on a parabola, and so here this parabola opens upward, so the vertex is right there. It's the bottommost point of the parabola. And how we find the vertex is that is an ordered pair. It's an actual point, so it's an ordered pair. So how I would find that is I'm going to have an x-coordinate and a y-coordinate, and the x-coordinate of the vertex is actually what the axis of symmetry is. See how the axis of symmetry, that's this red line here, goes straight through the vertex, so they're actually going to share here the x-coordinate. So that's going to be opposite of b over 2a, and then to get the y-coordinate, I'm going to plug in that value for x into my equation and solve for y. Now, when I say opposite of b over 2a, opposite of b is I'm using whatever number is in for b, whatever number is in front of x. So again, b is whatever number is in front of x, and a is whatever number is in front of x squared. So those are going to be filled in here with numbers with our given equation. Those can change with any equation. So again, the axis of symmetry is that line that cuts straight through the parabola, and then the vertex is either the lowest point or the highest point, so the maximum or minimum of a quadratic. And how I find that ordered pair is for my x-coordinate, opposite of b over 2a, when I get my x-coordinate, I plug that x-coordinate in wherever I see x and solve for my output y in that equation. Now my y-intercept is where my parabola intersects with the y-axis. And here, it's kind of covered up, but it'd be somewhat right there where that parabola crosses the y-axis. And how I find my y-intercept, it's very simple. It's 0, comma, c. So I'm going to plug in 0 for x and see what c is. But here, if I plug in 0 for x and 0 for x, 0 times anything is just 0, so it doesn't matter what numbers a and b are. It's just going to be whatever c is for my y-intercept, and that will always work for any quadratic. So 0, comma, c. And again, c is just the number that we're given from our quadratic equation. A couple other pointers for quadratic function basics. If a is greater than 0, and here a again is the number that's in front of x squared, if a is greater than 0, your parabola opens upward, so it's an open U-shaped graph. So I'll write opens up, and therefore your parabola will have a minimum. Now, why will it have a minimum? Because see here, you'll have the lowest point because your parabola will open up. So you will have a minimum. And again, that is if a is greater than 0. Now, if a is less than 0, this is going to be the opposite. So if a is less than 0, your parabola opens downward, opens down, and this will have or has a maximum. So again, if it opens downward, it'll have a highest point for the vertex, so that will be a maximum there. Okay, let's practice graphing a quadratic function using a table of values, and then we'll find the domain and range. So here our quadratic is y equals x squared minus x minus 2. So here I'm going to graph this parabola by making a table. So I'm just going to choose values for x such as -3, -1, 0, 1, and 3. So just a couple of different values to graph this parabola. So I'm going to plug in these values in for x and solve for my output y. So I'm going to go ahead and plug in -3 in for x into my quadratic. So y equals -3 squared minus -3 minus 2. -3 squared is 9, minus -3 is really plus, minus 2 equals 10. And I'll fill in my table in just a moment. Now I'm going to plug in -1 in for x and do the same thing. -1 squared is 1, minus -1, chop is plus, minus 2 is 0. Then third, I'll plug in 0 in for x, so 0 squared minus 0 minus 2. 0 minus 0 minus 2 is just -2. Now I'll try 1, plugging in 1, so y equals 1 squared minus 1 minus 2. So 1 minus 1 minus 2 is -2. And last, y equals 3 squared minus 3 minus 2. And that would be 9 minus 3 minus 2, which is 4. And now I'm going to go back and plug these values into my table. Okay, now I've placed those values into my table, and now I'm going to graph those ordered pairs. So -3, 10 would be right there. -1, 0 would be right here. 0, -2 right there. 1, -2 be right there. And then 3, 4 would be right there. Now, if you recall with quadratics, you have a U-shaped graph. It's a parabola. So I'm going to connect these ordered pairs and make my U-shaped parabola that goes through all of these points, and there's my parabola. Now, the domain, if you can recall, from linear equations, the domain represents all of your x values, or as you look at your graph from left to right, what values could be on your graph. Well, if you look at your parabola has arrows that are going upward. That means your parabola is going to go on forever. And your parabola is going to go up and get wider and wider as you keep including more numbers in this parabola. So your domain is actually, for all the x values you could be, or this graph could be, you could plug in whatever you wanted. And again, your parabola is going to open up and get wider and wider, and it's going to go on forever and ever. So really, it's not going to matter what values there are for x, and there really is no limit. So your domain, again, represents all the x values, is all reals. And a way we can incorporate all reals with a symbol is this all reals sign right there. And again, I could write all reals or that R with two lines through. Another way I could write all reals is I could say for every x value, x is less than positive infinity because we don't know what infinity is, and it's got to be greater than negative infinity. So it's strictly bounded between negative infinity and positive infinity. It can't be equal to them because, again, it goes on and on forever. There is no bound to infinity. Now range represents all of the y values, so now we have to look at our graph from top to bottom. We have to figure out what values we can actually hit. So we know our arrows are going upward here on this graph, so we're going to go to infinity. So for all y values, y is strictly has to be less than infinity. But we don't know what infinity is, so we have to strictly be less than it. But we know we're going to have a lowest point on our graph. So I'm going to wait to fill in this half until I figure that out. Our lowest point here is going to be right around here, and that will be part of our vertex. And we don't know quite what our vertex is, so we have to find it. So if you can recall from our last page of notes, we need to figure out for the vertex the opposite of b over 2a, and then plug that value in to find y. So here what I'm going to do is I'm going to find this vertex. So again, in my equation, y equals x squared minus x minus 2, is I'm going to figure out what the opposite of b over 2a is. So here, x equals opposite of b, and b here is negative 1, so what's the opposite of negative 1? Positive 1 over 2 times a. What's a? Well, a again is in front of x squared, b again was in front of x, and there's a 1 in front of x squared, so 1 over 2 times 1, which equals 1/2. So that's the x-coordinate of my vertex, 1/2, comma, now I have to find the y-coordinate. So to find the y-coordinate, I have to plug in 1/2 in for x and solve for y. So 1/2 squared is 1/4 minus 1/2 minus 2, which is negative 2.25, or, negative 2 1/4. So my vertex is 1/2, negative 2.25. So let's go up to our graph and let's look at this and see if that makes sense. So again, our vertex that we calculated was 1/2, negative 2.25. So let's look. That would be over 1/2 on the x-axis, down negative 2.25. That does look like it is right. So with our vertex, negative 1/2, negative 2.25, this y value here, this negative 2.25, tells us how far down on the y-axis or on the y scale that we are. So that's actually the lowest point of our graph. So with this range, we know our lowest point, again, is our vertex, the y-coordinate of our vertex. So now for our range, we are going to say negative 2.25 is less than or equal to y, which is less than infinity. Because y can be negative 2.25, we saw that with our vertex, but it's strictly got to be less than infinity. And now we have our graph for our quadratic function using a table of values and calculating the domain and the range. We are going to skip example 1b for now and go on to the next example, example 2a. Example 2a says, using the graph, find the vertex equation of the axis of symmetry and the y-intercept. So given the graph here on the left, let's find those missing pieces of information. The axis of symmetry. If you can recall, the axis of symmetry cuts your parabola straight in half, and it goes through the vertex. So here if I draw that in, and I'm going to zoom in here, I drew that axis of symmetry in purple. Now, what is that axis of symmetry? Well, again, it's in the form of a line, so it's x equals, and what does that value look like? Well, if we count on the y-axis, it's over 1, 2. It's over 2 units, so the axis of symmetry is x equals 2. The vertex is either the lowest or highest point, and since this parabola opens up, our lowest point is going to be actually a minimum. So let's look at that red point there, and let's calculate what that is. It's over 2 units, down 2 units, so our vertex is 2, negative 2. Again, it's an ordered pair. The y-intercept is where your parabola goes through the y-axis. So if you can look, it's in blue, and it's actually up 2 units where you see this line here crosses the y-axis. So the y-intercept would be in the form of 0, comma, a number, and here it is 2. 2b is very similar to 2a, and we just need to figure out the missing pieces of a graph here of a parabola. So the axis of symmetry is already drawn in for us right now, and that's that dashed line that goes through the vertex that cuts the parabola in half, and that here is over 2 units. So it would be x equals 2. Again, it's in the form of a line. The vertex here would be our highest point because the parabola opens downward. So if I figure out where that ordered pair is, it's over 1, 2, up 1, 2, 3, 4, 5. So 2, 5. And then our y-intercept is where our parabola crosses the y-axis. Here it would be down 4 units. It's in blue. So 0, 4. All right, last example, example 3. Find the vertex equation of the axis of symmetry and the y-intercept of the quadratic function. Now, we have to find these pieces of information mathematically because we're not given a graph. So right now, let's locate what is a, b, and c. A is -2, b is -8, and c is -2. So the axis of symmetry is x equals opposite of b over 2a. So here for our example, we would have x equals opposite of b, which would be opposite of -8, which is positive 8 over 2 times a, and a is -2. So we have 8 over -4, which means x is -2. So that's the axis of symmetry. Now to find the vertex, we are going to use part of the axis of symmetry because if you can recall, the x-coordinate for the vertex is opposite of b over 2a, and then you plug in what you have for x into your quadratic equation to solve for y. So we actually have half of our vertex figured out if we already have the axis of symmetry found. So let's plug that, or let's plug in our x-coordinate, which we know is -2 from, again, up here with the axis of symmetry. So I'm going to say y equals -2, and now here's where I'm plugging in my x-coordinate, -2 squared minus 8 times -2 minus 2. So y equals -2 squared is 4. 4 times -2 is -8. Minus 8 times -2 is 16. -16, so if I minus a negative, that's really plus 16, and then minus 2. So do those calculations, and you get y equals 6. So your vertex is -2, 6. Last but not least, the y-intercept. If you recall from our notes, this is whatever c is in the form of 0, c, because if we were to plug in 0 for x up here, right here, and here, 0 times anything is 0, minus 0 times anything is 0, minus 2 would be -2 for our y-intercept. So here our y-intercept is 0, -2. Thanks for listening to the beginning of Chapter 9. Please check Google Classroom for your assignment. Have a great day.